Alright, today we're going to break down the basics of volume and do a little bit of review and then add some complexity to it because, well, why not? Let's learn. When taking on volume, we start by looking at the idea of breaking down, in this case, a cube into lots of smaller cubes. And so how many cubic units is this cube? All right, so by looking at this diagram, we notice that we're going 4 units up by 4 units across, and then finally we would say 4 units deep. And from here we come away with this idea. Volume is length times width times height. And if I want to change all those colors, that would be, what would I need to change these guns? All right, I'll color coordinate it for you. Oh man, I'm really messing up. Height is in blue. Length would be in, oh, let's just call it length. And then red is going to be our width. So we have those different. What do you mean? You can't see the colors? You can't tell the difference? Sorry for wasting your time. Moving on. Length times width times height. With this in mind, we have 1, 2, 3, 4 for the height. We have 1, 2, 3, 4 for the width. We have 1, 2, 3, 4 for the length. So 4 times 4 times 4, 4 cubed in essence. Get it? Cubed. Okay, it wasn't really a pun. It's just what it is. But 16 times 4 for those people who don't want to deal with that. 16 times 4, of course, is 64. And we're measuring in cubic units, so we're doing units cubed. Okay. Another way to look at this idea is, okay, the lines aren't there, but how many of those cubes that we just saw in the picture before would now fit into this box? Okay, to solve that, we're going to still use our formula. Volume equals length times width times height. With that in mind, then I'm going to take, well, you can kind of break it down in any order because you have the commutative property of multiplication, right? 6 times 5 is 30. I think that's easier here. 30 times 10 gives me 300. And so because it's asking for cubes, this time I would say it's 300 1 centimeter cubes. Right? So 300 cubes there. And so we have that breakdown. All right, that's a review. Let's talk about what happens when you get a complex shape. When you get a more complex shape and you want to find volume, initially it's going to look something more like this, except for it might not have all those wonderful little cubes there to help you identify things. It might just be numbers, 3, 2, and 4, just like that. And they might give you an extra number here. But we need to break it down. And by breaking it down, we're going to divide it into 2 different 3D shapes that we can find the area of. And so we have the green shape, which is 2 by 2 by 4. So 2 times 2 times 4, right? Length times width times height. And then we have the yellowish color, which of course is, we got 4 by 4 with a height of 1. So 4 times 4 times 1. And as you break this down, you're going to come away with an answer of 16 and an answer of, not 8, 16. And then because we want total volume, we're going to add the 2 together. So by adding the 2 together, I get 32 units, and then of course cubed, just like that. And so we have that concept. So how do we take a complex shape and break it down? Your turn. Cool little sample word there. Okay, all the information is there. Break it down into 2 shapes. Solve. All right, a couple more problems then. Let's talk about this. How do we take volume and really get a good application of it? Right, we see a fish tank has dimensions of 40 centimeters by 15 centimeters by 12 centimeters. Okay, so you should be able to find the volume. Okay, if a 1 centimeter cubed, right, so one of those blocks, one of those cubes, is equal to 1 milliliter, about how many liters of water fit in this fish tank? All right, let's break this down piece by piece. First of all, we need to figure out the volume. Okay? By determining the volume, we're going to take our 40, we're going to multiply by 15, we're going to multiply by 12. Now you can determine which is the easiest to multiply by first. 15 times 12 or 40 times 15, or you're just going to take out your handy dandy calculator and you're going to do it that way because you've established that you know what the numbers are and that you need to multiply. And once you do that, you're going to come away with an answer of 7,200 centimeters cubed. Right? 7,200 centimeters cubed. With that in mind now we need to take on the second part of the problem, right? 1 to 1, right? So it's a 1-to-1 ratio. So if I have 7,200 centimeters cubed, how many milliliters do I have? Well, that's going to very quickly translate into this idea. All right, so now I got the milliliters. Oh yeah, that was a lot easier than you thought it would be. All right, well, here's our last question though. How many milliliters equal 1 liter? Hopefully you're saying, oh, I know that. That's 1,000. Okay, so 1,000 milliliters equals 1 liter. If I have 7,200 milliliters or 7,200 milliliters, how many liters do I have? And so I need to take this, and I'm going to use a unit multiplier. I want liters as my answer over 1,000, 100, 1,000. And so we have that. We're going to multiply, right, and come away with a final answer of, all right, I'll show all my work. I'll show all my work. Right, divided by 1,000. Right? And so we have this idea divided by 1,000, which equals 7.2 liters. So breaking down problems gets us to an answer. And if we take a step by step, it doesn't look as monstrous. So in the end, I might say, well, how many gallon tank is that? And hopefully you're saying less than 2 or about 2, which means that's a pretty small fish tank. I hope he's not getting as many fish picture as what's pictured there. What? I was going to give that as a sample to you? Oh, man. Go back in time a little bit and just don't do that problem. And let's do it together in class as a challenge. All right? All right, you have your sample problem. That's the end of the video. I took this really cool problem and I showed you how to do it when I wanted you to show me how to do it. If you have questions, come with questions. That is lesson 70.